In this question, we're asked to draw the Lewis structure of CH2O. And in several other videos, I've used these steps. I'm going to use them here pretty quickly. So the first step is to count the valence electrons. So 4 for carbon, plus 2 times 1 for the 2 hydrogens, plus 2 times 6 for the 2 oxygens. That gives me 4 plus 2, which is 6, plus 12, which is 18 electrons. Least electronegative atom in the middle, with the exception of hydrogen. Hydrogen never goes in the middle. So we put carbon in the middle. We bond it to a hydrogen. We bond it to a hydrogen. We bond it to an oxygen. We bond it to an oxygen, because we have 2 hydrogens and 2 oxygens. I've now used 4 bonds, or 8 electrons, which leaves me 10 left. 2, 4, 6, 8, 10. Hydrogen only wants a duet, because it wants to be like helium, and this oxygen has an octet. However, this one doesn't. Note that I would normally use a multiple bond to fix that. But in order to do that, I would need a lone pair on carbon in order to make a multiple bond. If I had a lone pair on carbon, or I made a multiple bond, or whatever the case may be, I would expand the octet of carbon, which is a violation of the rules. So this Lewis structure is actually not possible. I can't have only one central atom. So I need to try it again, because I can't fill the octet. No matter what I do here, I can't fill the octets. So I need to try again with multiple central atoms. So what I want to try to do is draw H, bond C, bond O, bond H, bond O. So now I have 2 central atoms. This carbon is central, and this oxygen is central. I now have 1, 2, 3, 4 bonds, or 8 electrons, and I have 10 left. So let me fill octets. 2, 4, 6, 8, 10. I now have filled the octet of both of the oxygens. But what you'll notice is that carbon doesn't have an octet, which is not ideal. However, in this case, I can move electrons in order to fulfill carbon's octet. I can move these 2 here into a double bond to fill carbon's octet, or these 2 here into a double bond to fill carbon's octet. So let's see what those 2 things look like. H bond C, if I move these 2, double bond O, bond H, and this has its electrons. Or I can move these 2, not these, and what I would end up with, I'm going to write that up here, H bond C, bond O, double bond O, bond H, and 1 lone pair. In both cases, I've filled everything's octet, whether I move these 2 or these 2. So which is better? It's all about the formal charges to determine which is better. So in this case, oxygen wants to have 6 electrons around it, and this oxygen has, count the dots as 1, count the dashes as 1, 1, 2, 3, 4, 5, 6. It's neutral. This oxygen wants to have 6 electrons around it, and it has 1, 2, 3, 4, 5, 6. It's neutral. Carbon wants to have 4 electrons around it, and it has 1, 2, 3, 4. It's neutral. Everything is neutral. That looks great. Let's check this one, just to make sure. Carbon wants to have 4 electrons around it, and it has 1, 2, 3, 4. It's good. Oxygen wants to have 6 electrons around it, and this particular oxygen has 1, 2, 3, 4, 5. It's missing an electron, so it's plus. This oxygen has 1, 2, 3, 4, 5, 6, 7. It has an extra electron, so it's minus. This Lewis structure has formal charges. This one does not, making this one better. So this is the best Lewis structure for formic acid. And if you were actually to look this up on the internet, you'd find that this is the Lewis structure of formic acid.